Hi guys, this is a complex number question, exam 1 style, and it is quite a curly little question. It's well worth us going through this together, but I'd like you to have an attempt at it first and then come back to me when you're ready, okay? See you soon. Alright, you're back. Well, what did you think? Yes, it's a bit curly and a bit tricky. I'll go through what I did for you, and we'll see if that sheds any light on the subject, or maybe it confirms your brilliance in specialist maths. So, part A, we're going to express 1 plus root 3i in polar form, and that's very straightforward, part A. So we just get the value of the modulus, which is r, which works out to be square root of 4, positive square root of 4, which is 2. Okay, no problem. And then the angle, the argument, that'll be the angle whose tangent is root 3 over 1, because the complex number is in quadrant 1, and therefore that would be pi on 3, wouldn't it? Yes, did you get that? Jolly good on you if you did. Now, that's the answer to part A. Now, part B is where the trouble starts. We've got to solve the quadratic equation z squared minus 2z minus root 3i equals 0. And remember, this is a by hand exam 1 style question. Expressing your answer in Cartesian form, expressed in the form z equals a plus bi, where a and b are real numbers. Alrighty, let's go with it. There's our quadratic equation. So let's get all gung-ho and go for it, guys. I'm completing the square, and that's what I get. Do you agree with me? Yes, good. So therefore I get this now. Okay, agree? Right, now this is where the trouble starts. What are we going to do with this? Because that's what z minus 1 would be when we take the square root of both sides. And see, the problem with this thing is that's not lending itself to this kind of an answer for z at all, is it? So this is where you've got to get your thinking cap on and think, oh goodness, what am I going to do with this? So here's my go at it, alright? I'm saying I've got to get this thing here, plus or minus this thing here, right? So let's call u squared equal to that with the view of getting the square root, okay? Yes? And that would satisfy this line above, wouldn't it? For at least that part of it, for at least the right-hand side. Yes? Okay, so now what I'm doing now is I'm going to put it into polar form, and I'm going to do a demois on it. Yes? Pretty nifty, hey? Yes, so that comes to 2 cis pi on 3 plus 2k pi, where k is an integer. Yes, you know how to do that, don't you? Good. Now we're going to do the square root of that. So here we go. Therefore, u would be root 2 cis, or half the angle. Yes? Okay, now we'll just substitute our values of k. Start off with 0 and then go up to 1, and you'll get your two answers, which will be exactly this little beastie here, and which we will hopefully be able to put back into Cartesian form. So, let's do that. If k is 0, then u would be root 2 cis pi on 6. Yes? Elementary, my dear Watson. And if k is 1, u works out to be root 2 cis 7 pi on 6, which of course you've got to put in principal argument form, which would be root 2 cis minus 5 pi on 6, okay? Now, let's try and put those answers back into Cartesian form, and hopefully we'll be able to do that. So when k equals 0, we had this one here, didn't we? Yes, down here. So let's just put that back into Cartesian form, and we can. Isn't that great? Because we know what cos of pi on 6 is and sine of pi on 6, so we're in the clear, guys. This is good. Yes, agree? Yes, I've got it round the right way, haven't I? I haven't mixed these values up. No, that's right. That's cos of pi on 6 is root 3 on 2, sine of pi on 6 is a half. Everything's good. So that comes to that. Okay, very good. Now, when k is 1, same procedure, but we get that. Alright? So let's just finish up now. If z minus 1, harking back to here, if z minus 1 is this first answer, this one up here, then we just add 1 to both sides and we get z is that. Alright? And if z minus 1 was the second answer, which was this one up here, adding 1 to both sides, we get that there, and they are the answers. Yes, it was quite a curly little question, wasn't it? But well worth having a bit of an investigation of, and adding that little skill to our mindset in case you get something like that in an examination situation. All right, all the best to you, and we'll see you soon.